NASA's Perseverance Rover is one of the most ambitious and successful space exploration missions to date. It has achieved remarkable feats, from landing on the surface of Mars to collecting samples from the planet's Jezero crater. The rover has been exploring the surface of Mars for more than 2 years, gathering data and images that have allowed us to gain unprecedented insight into the red planet. But what signs of past microbial life has the Perseverance rover discovered on Mars? What has the Perseverance rover revealed about the history of water? Finally, and most importantly, how will the Mars sample caching system be used to bring rock and soil samples from Mars back to Earth? As part of NASA's Mars 2020 mission, the Perseverance rover is a cutting-edge, 6-wheeled exploration vehicle equipped with state-of-the-art technology to carry out its mission on the red planet. Standing at the size of a car and powered by a nuclear source, this rover is set to explore the Jezero crater in search of signs of past microbial life. In addition to searching for evidence of life, the Perseverance rover will also collect rock and soil samples that will help lay the foundation for future human exploration on Mars. Accompanying the Perseverance rover on its mission is the Ingenuity, the Mars helicopter. The first helicopter to fly on Mars is an impressive feat of engineering. On April 19, 2021, Ingenuity made history by successfully completing its maiden voyage, hovering 10 feet above the Martian surface for 40 seconds before touching down safely. During the flight, it recorded data, took photos, and relayed its findings back to mission control. This marks an important milestone in space exploration, as it further demonstrates that robotic exploration of Mars is possible. The Perseverance rover has made several important discoveries since it landed on Mars in February 2021. One of the most significant of these is the discovery of mineral deposits, which is a strong indicator of an aqueous environment existing in the distant past. Clay minerals are created when water interacts with other minerals, and their presence suggests that the planet may have once been home to flowing rivers and oceans. The presence of clay minerals also provides new insight into the geological evolution of the planet, giving us a better understanding of the history of our solar system. Recent discoveries of molecular fossils and organic molecules on Mars have opened up the possibility of past or present microbial life on the red planet. Molecular fossils are organic molecules that are chemically similar to those found in living organisms. They are good indicators of past microbial activity, as they are often preserved in the fossil record. Organic molecules, such as amino acids and hydrocarbons, are associated with life on Earth, and the presence of these molecules on Mars could provide evidence of past or present microbial life. In addition, the rover has found evidence of rocks and sedimentary deposits on the surface of Mars. These rocks hold valuable information about the geological history of the planet, offering a glimpse into its past environments and climates. They can reveal the presence of specific elements and their concentrations, and provide evidence of organic compounds that could indicate the potential for life on Mars. The sedimentary deposits also give insight into the water flow patterns on the planet, providing a better understanding of the evolution of the Martian environment. These findings are crucial in piecing together the history of Mars and its potential for supporting life. Another exciting discovery made by the Perseverance rover is the presence of minerals that form in the presence of liquid water on the surface of Mars, such as olivine, iron, and magnesium carbonates. These minerals have been detected in the Zeta Formation, the lowest exposed geologic feature in the Jezero crater that the rover is currently exploring. These minerals are a strong indicator of an aqueous environment existing in the distant past, and their presence suggests that the planet may have once been home to flowing rivers and oceans. This is an important discovery because it implies that Mars may have had a warmer, wetter climate in the distant past, providing conditions that could have been favorable for the emergence of microbial life. The samples of these minerals have been stored on the rover in the hope that they may be brought back to Earth for further analysis in the future. The rover has also discovered salts called perchlorates, which are believed to have formed when Mars had liquid water. Perchlorates are hygroscopic, meaning that they can absorb water from the atmosphere, and their presence on Mars provides additional evidence for the existence of liquid water on the planet in the past. So far, the Perseverance rover has collected 4 samples from the ancient river delta on Mars, which were drilled out of rocks that show this part of Mars could have potentially supported Earth-like organisms in the past. These samples are now ready to be launched back to Earth in 2033 as part of the Mars Sample Return Program. The program is currently in its conceptual design phase and will involve an Earth return orbiter provided by the European Space Agency and a NASA-built lander to retrieve the samples. Perseverance will then drive over to the lander and deposit its samples, which will be launched off the Martian surface aboard a rocket carried by the lander. The Earth return orbiter will then snag the samples in Mars orbit and bring them back to Earth. Given the recent groundbreaking discoveries on Mars, do you believe that it is likely that the rover missions will discover extraterrestrial life on the Red Planet? Share your thoughts and insights in the comments section below. Thanks for watching.